Solving systems of linear equations by using substitution. What does substitution mean? To solve a system by substitution, you'll replace a variable with another expression. You're basically plugging one equation into another equation. So the steps to solve by substitution are that you pick one equation and get one of the variables by itself, either x or y, and then substitute this equation into the second equation. Solve for the variable, and once you get a number for one of the variables, you can take that number and plug it in to get the second variable. Let's solve this system of equations by using substitution. If we look at what we have, or the two equations that we have here, the second equation is just x equals -1. So the variable x is already by itself in this second equation. So we can go ahead and take -1 and plug it into the other equation, or substitute it into the other equation for x. So let me rewrite 3, and then I'm plugging in -1 where the x is, minus 2y equals 7. Alright, 3 times -1, that's -3, minus 2y equals 7. So remember, I had said before that you can't solve an equation that has two variables. So we just did this and we substituted in for x. So now we only have a single variable. We only have y in the equation. So we can solve this because it's only got one variable. So we want to get that variable by itself. I'm going to add 3 to both sides. And that gives me -2y equals 10. Divide by -2, and I get y equals -5. Okay, so if I were solving a system where both equations had an x and a y in it, I wouldn't be done. I would have to take -5 and plug it in to get x. But in this system, we already had x by itself. We already knew what x was. If we look back at the original equations, x is -1. So we have x and we have y. Our solution should always be an ordered pair, because remember, a solution to a system, if we think about it graphically, is where the two lines are crossing each other. So we need a point. We need to know the point where the two lines cross, and that would be -1, -5. We always write our solution as an ordered pair, x and then y, like that. So in this case, it's -1, -5, and that's the solution to this system. Okay, so let's look at another system of equations. In this system, the first equation has y by itself. Y equals -2x plus 5. So we take what the variable is equal to. Y is equal to this. And we're going to substitute that expression into the other equation for y. So let me rewrite the second equation with the substitution. So x plus 2, and I'm going to substitute in what y is equal to, -2x plus 5 equals 1. So all I did, I replaced y in the second equation. This was a y. I replaced it with what y is equal to. Now I just need to simplify this. So the first thing I need to do is get rid of the parentheses by distributing. So that gives me x, and then 2 times -2x would be -4x, plus 10 equals 1. Now I'm going to combine like terms. X and -4x would be -3x. I'm going to subtract 10 from both sides. And I have -3x equals -9. Divide by -3. And I get x equals +3. Okay, that's my x. So remember, I'm looking for the ordered pair that is the solution to my system. So I can take 3 and I can plug it into either of the original two equations. It doesn't matter which one, you'll get the same answer either equation that you plug it into. But since I'm looking for y and that first equation already has y by itself, I think that would be the easiest to plug it into. So when I do that, I get y equals -2, and I'm plugging in 3 for x, plus 5. Alright, so that would be -6 plus 5, which is -1. So the solution to my system is 3, -1. In this next equation, when we look at the two equations, the second equation has a variable by itself. The x is by itself in this second equation, so I'm going to take what x is equal to y minus 3, and I'm going to plug it into the other equation where x is. Since x equals y minus 3, I can replace x with y minus 3. Alright, so 2, I'm replacing it with y minus 3. Plus 5y equals 15. Okay, so I want to simplify. I'm going to distribute the 2, and that would give me 2y minus 6 plus 5y equals 15. If I combine like terms, 2y plus 5y is 7y. And then I'm going to add 6 to both sides. That gives me 7y equals 21. To get y by itself, I need to divide both sides by 7. And y equals 3. Alright, am I done? No, because I have to find out what x is. So I'm going to take the 3 and plug it into either one of these two original equations. But again, since I'm looking for x and the second equation has x by itself, that would be the easiest one to plug it into. So I'm going to plug in 3 right there where the y is. So that gives me x is equal to 3 minus 3, which is 0. So my solution is 0, 3. Number 4 gives us 4x equals y, and 4x minus y equals 7. Well, in the first equation, 4x equals y, the y is by itself. So I can take what y is equal to, which is 4x, and substitute it into the other equation where the y is. So that gives me 4x minus, I'm plugging in 4x, equals 7. Well, 4x minus 4x is 0. So when I simplify, I get 0 equals 7. Does 0 equal 7? No, that's not a true statement. So if I get a statement, if my variables cancel out and I have a false statement, that means there's no solution. So remember, graphically, that just means these two lines are parallel. They don't cross each other, so there's no solution. All right, in this equation, if I look to see if there's a variable by itself, the second equation has x by itself. So I'm going to take what x is equal to and substitute it into the other equation for x. So if I plug that in for x, if I plug in 2y plus 1 minus 2y equals 1. Now, it's always important that when you plug something in, you plug it in parentheses. In this case, it really doesn't matter because there's nothing in front of the parentheses, and I can just erase the parentheses and nothing changes. But say, for example, if the variable had been right here, say if I had minus x right there, when I plug something in for x, there's a minus sign in front, and I would have had to have distributed that minus sign into the parentheses. So it's always important that when we plug stuff in, we plug it in parentheses, and then if there's something in front, we're going to have to distribute it to everything that we just plugged in. Like I said, it really doesn't matter with this one because there was nothing in front of what we plugged in. Okay, so now I'm going to combine my like terms. I have 2y and a negative 2y, and when I combine those, they cancel out, and I'm left with 1 equals 1. So again, my variables canceled out, but this time I have a true statement. 1 does equal 1. So if my variables cancel out and I have a true statement, that means I have infinitely many solutions. Remember, this means that I have two lines that are the same, and so they share every point. So every point is a solution. That's infinitely many solutions. Now, if I look at this equation and I try to find the variable that's by itself, there's not a variable that's already by itself on one side of the equation. So if that's the case and I want to use substitution to solve the equation, I have to get a variable by itself. Well, you always want to try to get a variable by itself that doesn't have a coefficient or the coefficient is 1. Because say if I chose this to try to get that by itself, I would need to divide everything by 2, and then that might cause me to have fractions. So if I choose to get this y by itself, that's going to be the easiest thing to get by itself because its coefficient is 1. So to get the y by itself in that equation, I'm going to subtract 2x from both sides. And that leaves me with y equals, I can either write 6 minus 2x or negative 2x plus 6, it doesn't matter. So now I have a variable by itself. Okay, so I'm going to take what that variable is equal to, the y is equal to this, and I'm going to substitute it into the other equation where the y is. Okay, so when I do that, I get 3x plus 4, and I'm substituting in parentheses, negative 2x plus 6 equals 4. Alright, so now I need to distribute the 4. So that gives me 4 times negative 2x, that's negative 8x, plus 24 equals 4. If I combine my like terms, 3x minus 8x, that's negative 5x. And then I'm going to subtract 24 from both sides. So that gives me a negative 5x equals negative 20. Divide by negative 5. And x equals a positive 4. Okay, that's my x. I still need y. So again, I could either plug this into either one of these original equations, or this equation is still one of the original equations. It's just rearranged. And since I'm looking for y, it would be easiest to plug it into that equation since that equation has y by itself. Alright, so that's what I'm going to do. I'm going to take the 4 and plug it in right here. So that gives me y equals negative 2, and I'm plugging in 4 for x, plus 6. So that would be negative 8 plus 6, which is negative 2. So my solution is 4, negative 2.